Now see here, there is a capacitor having capacitance C and a bulb is connected in series with the capacitor and source is connected here, and this source can be AC or DC. So, we can change and we can see the variation in the brightness of the bulb. Suppose we have taken first AC source over here, not DC. So, when you are taking AC source, then capacitive reactance applied by capacitor is, that is Xc is equal to 1 upon omega C, that is 1 upon 2 pi nu C. So, according to the frequency and capacitance, bulb will be glowing, brightness will depend on the value of the Xc. So, if you decrease capacitance here, value of C if you are reducing here, then what will happen? X is increasing. So, if you reduce C, the brightness of the bulb will be, what happens here? If it is reducing the C, it is increasing, that means the brightness of the bulb will be reducing. Now, if you increase frequency, the same thing happens. Xc, if you increase frequency, Xc will be decreasing. As a result, the brightness will be increasing. So, that depends on the value of C and nu, what is the brightness of the bulb in the AC circuit. But what happens if you are taking this source is suppose DC? When you are connecting to the DC source, what happens? Capacitor start getting charged. When the capacitor is fully charged, and then it blocks DC. You know it, that is already we have done X is equal to 1 upon this is here 2 pi nu C, and nu is equal to 0. So, then Xc will be coming here infinite. When the capacitor gets fully charged, then what happens in this case? It blocks DC, it does not allow to flow the DC. As a result, bulb will not glow.